Hello, everybody. We're going to go over section 3.2 today on simple interest. So interest can either refer to a percentage-based return on an investment or a percentage-based fee on a loan. In either case, the calculation is the same. We call the starting amount for the loan or investment the principal amount. At a basic level, the amount of interest is a percent of the principal amount. So example 1, you were charged 12% in interest on a loan of $3,500. How much interest do you owe on the loan? So as we did in earlier sections, we can calculate 12% of 3,500 as 0.12 times 3,500 or $420. Remember, you must always convert percents to decimals or fractions in order to perform calculations with them. So you owe $420 in interest on this loan because that's 12% of 3,500. Of course, the amount of interest usually goes up the longer the account is open. There are several mathematical models to represent this, the simple of which is aptly named simple interest. Simple interest is given by the formula I equals PRT, where I is the amount of interest, P is the principal amount, R is the interest rate as a decimal, and T is the amount of time that the account is open. Because interest rates are almost always given in years, for example, a 6.8% annual interest rate, whenever the duration of an investment or loan is given with a different unit of measurement, we must first convert it to years. Several common conversions are listed below. So 1 year could be 4 quarters, it could be 12 months, it could be 52 weeks, or it could be 360 days. And I know what you're saying. You're saying 365 days in a year. You're wrong. Well, while one calendar year is usually 365 days, we use the banking convention of all months having exactly 30 days. So in banking terms, 1 month is 30 days, therefore 12 months would be 360 days, not 365. Example 2. Cody financed a home improvement project which cost $5,800 for 18 months at 5.2% simple interest annually. What will be the financing fee on Cody's loan? So let's use our 4-step problem-solving process and understand the problem. We start by listing out our knowns and unknowns using our standard variables. So I, P, R, and T for the formula I equals PRT. I is our unknown. We're asked to find the amount of interest. P, the principal amount of the loan, would be $5,800. R would be 0.052 because we need to translate the 5.2% interest rate to a decimal. The decimal point moves 2 spaces to the left, 0.052. And T is going to be 1.5 because we have 18 months divided by 12 months per year, which gives us 1.5 years. Step 2, devise a plan. We recognize that this is a simple interest problem, which means we can solve it by substituting the known values into the simple interest formula. So let's carry out that plan. We have I equals PRT, and we substitute for P, we substitute for R, and we substitute for T. 5,800 for P, 0.052 for R, 1.5 for T, 1.5 years, 18 months. Using our calculator, we find that multiplying these together gives us 452.4. So Cody will be charged a $452.40 financing fee. In example 3, Zach takes out a 15-day payday loan for $750 at 35% simple interest annually. How much will Zach pay in interest? So again, let's list out our knowns and our unknowns using our standard variables, I, P, R, and T. I, again, is our unknown because we're asked to find the amount of interest. P, in this case, is $750, the principal amount of the loan. R is 0.35 because we convert the 35% interest rate to a decimal. And T is going to be 15 over 360 because it's a 15-day payday loan. There's 360 days in the year, and we're timing out for 15 of those. So 15 out of 360. Notice we could reduce 15 over 360 to get 1/24th, but since we're just going to take these numbers and punch them into a calculator, there is no advantage to doing this. So we can just leave it 15 over 360. Once again, we recognize that this is a simple interest problem, which means we can solve it by substituting the known values into the simple interest formula. So let's do that. Replace P with 750. Replace R with 0.35. Replace T with the fraction 15 over 360. Or on the calculator, you could multiply by 15 and then divide by 360. So 750 times 0.35 times 15 divided by 360 gives us an I of 10.9375. Rounding to the nearest cent, Zach will owe $10.94 in interest on this loan. Example 4. Sam paid $61.20 in simple interest on an 8-month loan at 10.2% annual interest. What was the principal on the loan? So this time we're not asked for the interest. We are asked for the principal. We're given the amount of interest. So this time our unknown is P. We're asked to find the principal amount. I, the amount of interest, is 61.2 because there's $61.20 in interest. R is 0.102 because we translated 10.2% interest into a decimal. And T is 8/12 because there's 12 months in the year and this loan is for 8 of them. So 8/12 of a year, 8/12 is T. Again, there's no point in reducing that because we're just going to plug these things into the calculator. So once again, this is a simple interest problem, but this time we need to solve for P in the formula. So let's plug in what we know. We know that I is 61.2. We don't know P, so it stays P. We know that R is 0.102, and we know that T is 8/12. So we simplify on the right a little bit by multiplying the 0.102 times 8 divided by 12, and that gives us 0.068. So the right side of the equation becomes 0.068P. To solve for P, we do some algebra, divide both sides by 0.068, and 61.2 divided by 0.068 is 900. So 900 is P. The principal on Sam's loan was $900. Let's talk a little bit about credit card interest. The financing charge on many credit cards is calculated as simple interest on something called the average daily balance of the credit card account. An average daily balance is just what it sounds like. It's the average of the balance on the credit card at the end of each day in the pay period. Average daily balance. So example 5. Sam begins the month with a balance of $123 on her credit card. After 10 days, she makes a payment of $85. On the 21st day of the month, she makes a purchase of $37. What is the average daily balance on Sam's credit card this month? So I've carried the problem over so we can still see it. Let's start our problem-solving process with understanding the problem. We're given the amounts of each transaction, but not the balance. So let us first correct that missing piece of information. Let's make this table. We have a column for days. We have a column for the transaction, a column to keep track of the balance, and a column for the duration, a count of how many days the balance remained at this value before a change or before the end of the month. Day 1, there was a $123 balance. It stayed that way for 10 days. The problem says after 10 days, she makes a payment of $85. So on day 11, there is a transaction of minus $85, leaving the balance at $38. It stays that way for 10 more days. And then on the 21st day of the month, she made a purchase of $37, which adds $37 to her balance. The balance is now $75, and it stays that way for 10 days until the end of the month. Carry that table over. Let's devise a plan. We're asked to calculate the average of the balance for each day. We can calculate this average by adding together the balance for all 30 days and then dividing by 30. But because of the way this problem is structured, we can take a shortcut to make our life easier. Rather than adding, for example, 123 plus 123 plus 123 plus 123, so on, so that there's 10 of those before getting to the next time the balance changes, we can multiply the 10 days that the balance stays at that same balance of 123. Doing this for each balance will make the calculation much more manageable. So we calculate the average as 10 times 123 plus 10 times 38 plus 10 times 75. Divide what we get by 30 and we get 78.6 repeating. Rounding that to the nearest cent, the average daily balance of this account is $78.67. Once we have the average daily balance on a card, that becomes the principal amount of the loan for the month. We calculate the finance charge as the amount of simple interest charged in 1 month with the principal amount of the average daily balance. So example 6, Sam's credit card from the previous example charges 27.5% annual interest. What will the finance fee be on Sam's credit card this month? So let's understand the problem from the previous example. We know that Sam's average daily balance for this month was $78.67. On this balance, she is charged 27.5% simple interest for 1 month. So we can substitute the known values into the simple interest formula and solve. We're looking for the interest. We're looking for I. The principal amount, the average daily balance of $78.67. R, our rate as a decimal, 27.5% becomes 0.275. And since this is for 1 month, that is 1/12 of the year, 1 month out of the 12 months. So T is 1/12. Plugging these things into the simple interest formula, we don't know I. P is 78.67. R is 0.275. T is 1/12. So 78.67 times 0.275 times 1 divided by 12 gives us from the calculator 1.802 and then a bunch of other numbers. But since we're rounding to the nearest cent, we can stop after the 2. We need to see that 2 to realize that the 0 does not round up. The finance fee for the month is going to be $1.80. Credit cards hate this one simple trick. So keep in mind that credit cards will charge a finance fee only if you start the month with a non-zero balance. So if you always pay your credit card in full on time, if you're always finishing the month with a 0 balance, you will never see a finance fee. You will only pay what you spend, no interest. Example 7. Kara begins the month by paying her credit card in full. On the 3rd day of the month, she spends $78.45 on groceries. On the 8th day of the month, she spends $32.78 on gasoline. On the 14th day of the month, she spends $47.95 at a restaurant. On the 17th day of the month, she spends $198.75 at the mall. On the 26th day of the month, she spends $74.82 on groceries. If Kara's credit card charges 32.33% interest, how much interest will Kara be charged this month? So there's a wall of text in this example, but the most important sentence is the first one. Kara begins the month by paying her credit card in full. If you start the month with a $0 balance, you do not get charged a finance fee. So there is nothing that we need to do for this problem. Kara will not be charged interest this month. Always pay attention to the situation and do not assume that you will need to use the details of a problem just because they are given to you. So that very first sentence, Kara begins the month by paying her credit card in full, means she starts with a 0 balance, meaning she is not getting interest that month. While calculating the amount of interest a loan or investment accrues is useful, we are usually more interested in the total value of the investment or the total cost to pay off the loan. We will denote this as A and note that A equals P plus I. In other words, the amount of the loan, the total value, is the principal plus the interest. For the case of simple interest, we know that I equals PRT, and we can substitute that in. So A equals P plus PRT. Or we can factor out that P and get it in the form A equals P times in parentheses 1 plus RT. Example 8. Zach takes out a 15-day payday loan for $750 at 35% simple interest annually. How much will it cost Zach to pay off the loan? Now, earlier in this lecture, we calculated the amount of interest Zach will owe. Let's ignore that and use this example to look at the new formula for simple interest. So let's list out the known and unknown parameters. A is unknown because we're asked to find the total cost for the loan. So that's A, and we don't know it. That's what we want to find. P, the principal, is $750. R, the rate, 35% becomes 0.35 as a decimal. And T, the time, 15 days out of the year, 15 out of 360. 15 over 360 is T. This is a simple interest problem, but since we're asked to find the total amount, A, we'll use our new variant of the simple interest formula. A equals P times 1 plus RT. Plugging in what we know, P is 750, R is 0.35, T is 15 over 360. So in the calculator, we would do 0.35 times 15 divided by 360, get our result. Add 1 to that, get our result. And multiply by 750. And that'll give us 760.9375. Rounding to the nearest cent, it will cost Zach $760.94 to pay back this loan. At times, you will hear P called the present value of the investment and A the future value. In this context, the present value is the amount of money that you have now to invest, and the future value is what that investment will be worth later. In example 9, Roger plans to start an investment today that will have a future value of $12,000 in 12 years. If his investment will earn 4.5% simple interest annually, what should the present value of the investment be? So as always, understanding the problem, we're going to list the knowns and the unknowns. And the unknown is P. We are asked to find the present value. What should the present value of the investment be? A is the future value given of $12,000. So A is 12,000. R, we convert our 4.5% interest rate to a decimal and we get 0.045. And T, the time in years, is 12. Future value of $12,000 in 12 years. So T is 12. This is a simple interest problem, so we will use the simple interest formula. The problem discusses A, so we will use that version of the formula. Our unknown is P this time, so we're going to need to do a little bit of algebra to solve the equation before we're done. So plugging in what we know into A equals P times 1 plus RT. A is 12,000. R is 0.045. T is 12. In our calculator, we multiply 0.045 times 12, get our result, add 1 to that, and we get 1.54. So the right side of the equation becomes 1.54 times P. Divide both sides by 1.54 to get P. 12,000 divided by 1.54 is 7,792.20779, and then a whole bunch of other numbers. We only need to see this first 7 to see that the 0 is going to round up to a 1. So rounded to the nearest cent, the present value of Roger's investment should be $7,792.21. One fairly common investment is to purchase a bond. A bond typically has a predefined length after which the bond matures. In this context, A is sometimes called the maturity value of an investment. Example 10. Treasury notes, or T-notes, are bonds issued by the federal government to cover its expenses. If Kara purchases a 5-year T-note for $500 at 3.5% simple interest annually, what will be the maturity value of this bond? As always, we'll list our known and unknowns to start it off. We're asked to find the maturity value. That's the future value. That is A, total amount. So A is our unknown. P, the principal investment, was $500. R, the interest rate of 3.5% as a decimal becomes 0.035. And T, the time in years, is 5 years. It is a 5-year T-note. We can see that this is a simple interest problem involving A. We can use that formula, which is conveniently already solved for the A we need. So once again, A equals P times 1 plus RT. Plugging in what we know, P is 500, R is 0.035, and T is 5. Multiplying together, 0.035 times 5, getting our result, adding 1 to that, getting our result, and multiplying by 500, we get that A is 587.5. So the maturity value of Kara's bond will be $587.50. And that is section 3.2. Next time I see you, we're going to go over the homework for 3.1 and 3.2. So make sure you try it.